Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is subsets. So it's a very popular question, as you can see from the likes, right? So what the problem statement says, that we are given with the unique elements array and we have to return all possible subset. That is what we call as power set, right? So the only constraint is that the solution must not contain duplicate subsets, and we can return the solution in any order. So let's see an example to better understand the question. That we are given with an array that is 1 2 3. So all the possible subsets of this array is empty 1 2 1 2 3 1 3 2 3 1 2 3, right? So let's see how we can solve this. So let's see the intuition or the idea behind solving this problem, what approach or algorithm we'll use. So as we have to find the power set for an array, right, we have to explore all the possibilities, right? We have to exhaust all the options. So backtracking is the algorithm that we will use, right? Because backtracking explores all the possible solutions, right? And it backtracks whenever any of the possible solution is not feasible, right? Or it will, if it is or any of the possible solution does not lead to a valid solution. So let's try to see the state space tree or the recursion tree for this. So at the start we will maintain a list, right? A temporary list for each solution, and there will be a global list where we will add the list that satisfies the solution, right? So in this problem the list will be the subset. So as we know that the empty list is also a subset of an array, so we'll add empty list into the resultant list. Now we can choose from 1 2 3 any of the options, like we can start with 1, right? So we can see with 1 how many subsets we can make, right? We'll then explore 2 and we'll see how many subsets we can make with 2, right? Then 3. We'll proceed in such a manner. So let's choose the option 1, right? So when we choose the option 1, means we have added 1 in the set, right? So as we have added 1 in the set, so this set with only element 1 is also a possible solution. We will add into the resultant list. Now we have standing at 1, right? We have added 1 into the set. So which other options we have, what are other options we have to add into the set? That is 2 and 3, right? So standing at 1, I can add 2 or 3 in the set. So let's add 2. So if I add 2, the set will become 1 comma 2. So we will add 1 comma 2 in the resultant list as well, because set 1 comma 2 is also a feasible or the desired solution, right? Desired subset. Now we are at 2, right? We have added 2 as well. Now we are at 2. The start pointer is at 2. What are the choices we have when we have already added 1 and already added 2? That is, only left is 3. So only element left is 3. So we have to add 3 only. So now the set becomes 1 2 3, and we will add 1 2 3 in the resultant list as well, right? Now the start pointer is at 3, right? So we have we are now at 3, we don't have any further possible options, right? So we have reached the end of the array. So what we will do, we'll backtrack, right? And whenever we backtrack, we remove 3 from the list, right? We undo the choice that we made whenever we backtrack. So we remove 3, we reach our intermediary node, right? That is 1, 2. We'll see here that whether, so we will from 3, right? We again went back to 2, right? As a when we backtracked, and on 2 the only option was 3 that we explored, so there is no other options at 2. So we'll backtrack from here as well. So at 1, so from 2 we backtrack to 1. So at 1 we explored 2, right? We chose 2 as an option. Now from 1 we will choose 3. This will choose 3. So we will choose 3 and we will add in the set as 1, 3, right? And we will add 1, 3 in the result as well, because this is a desired subset. Now again we are at 3, right? Again we are at 3, but again at 3 we don't have any further choices because it's the end of the array. So we'll backtrack, right? When we backtrack, we remove from the list the last element always, right? From here also we'll remove. So we remove the last element, that is 3, and we reach the node where the list list was having only one element, that is 1. Now we'll see when like from 3 we again went to 1, right? So we have from 1 we explored all the choices, that is 2 and 3. Now we'll backtrack from here as well, and when we backtrack, we remove the last element from the list. So now the list becomes empty, right? Now again we are at the start. Now we explored the first option, like we started with 1, right? And then we saw different combinations, like adding 1, 2, then 1, 3, 1, 2, 3. Now we'll start from 2. Now we'll choose 2 as the starting element. So if we choose 2, right, so the set becomes 2, and we'll add this set into the result, because subset 2 is also a valid result. Now at 2 we have only one option, that is adding 3, right? 3 is the option to add in the subset, right? So we'll add 3 and the set becomes 2, 3. So we'll add 2, 3 as well in the list of subsets, because 2, 3 is also a valid subset. Now at 3, from 2 we went to 3. Now at 3 we don't have any further possible choices because it's the end of the array. So we'll backtrack, and when we backtrack we remove 3 from the list. So we'll reach a node where the set was 2. Now at 2 the possible choice option was 3 that we explored, right? That has been exhausted and the result was given. So we'll again backtrack from here, right? And when we backtrack we remove the element from the list, right? And the list becomes again empty, right? Now we will choose the last option, that is 3, or we'll start now exploring our subsets starting with element 3. So when we choose 3, we add 3 in the subset, right? 3 in the list, and the subset becomes with an element 3. So we'll add 3 in the result subset list, right? And at 3 we don't have any further possible options, so we'll backtrack, right? So when we backtrack from 3, we'll reach again a state where the list was empty or the state was empty, then we'll return from here, right? Because we have explored all the possible options, right? And when we chose one, we explored all the combinations of the subsets starting with 1. When we chose 2, we explored all the subsets, all the possible solutions, right? All the subsets starting with 2 and similarly with 3. So, and we found our list of list or the list of subsets. So let's see the code part for it. We have initialized a list of list data structure, right? And we have named it as result, and we are calling the backtrack method, the helper method, that takes input as the resultant list of list, temporary list, the numbers array, and the start, right? So first of all, we'll add into the resultant list of list the temporary list. So at the start, the empty list will get into the resultant list, because empty list is also a subset. Now we will start the for loop from the start. So initially the start starts from 0. So we'll pick the first element. As we saw, we picked 1 at the index 0, and then we'll iterate till nums.length. So as we have to explore all the options, so first we'll pick the index 0, then 2 and 3, right? So when we picked the element at index 0, that is 1, so starting with 1, so we'll add that element first of all in the list. So 1 gets added in the list, right? And when 1 gets added into the list, we'll again call the backtrack method with the result temp list nums and I plus 1, right? Now I plus 1. Now we will go further. We'll go further to explore all the possible solutions or all the possible subsets starting with 1. So 1 has already been added, so we have to try out the options starting with the index I plus 1, because at I, 1 is already added into the set. So that's why we are adding I plus 1. And once we have explored a solution, like we have traversed a solution and we have added into the resultant list, will backtrack. So whenever we are backtracking, we are removing from the list the last candidate or the last option we added into the list. So that's this line. This is important. So whenever we are backtracking, we are removing from the list and the last element. So from the temp list, we remove the temp list dot size -1. So temp list dot size -1 will point the last element of the list, right? So now when we backtrack and then we'll explore 2, right? For with 2, all the subsets starting with 2, all the subsets starting with 3. So that's why there is a for loop from the start till nums.n. So when we took 2, we explored the other choices starting with I plus 1. So if this is I, then we have to, explore the other possible solution starting with I plus 1. So let's talk about the time complexity for this. So as you can see, we are almost either picking. So there are 2 possibilities for every element in the array, right? If 1, 2, 3, so either this element, either we can have a subset starting with 1 or not starting with 1, right? So there is the choices, every element has it 2, right? So the total choices will be 2 to power n, right? And now we are copying the list, the temporary list, into the resultant list. So suppose we have the n elements, right? So the 2 to power n for the choices into n for copying the element into the list. So total time complexity will be big O of 2 to power n into n, and the space complexity will be, so as you can see we are maintaining a stack, right? So backtracking follows DFS, depth first search. So for the depth first search, the space complexity of the implicit stack is the height of the tree, right? And the height of the tree can be worst case big O of n, right? So the space complexity will be big O of n, plus we are maintaining a list, temporary list, that can hold elements up to n, right, at any point in time. So the worst case, the temporary list can have all the elements, so it will be big O of n. So we are ignoring this resultant space complexity for now. Then the space complexity will be order of n plus n, that is big O of n. So yeah, test cases are accepted, so it means it's running fine. So if you like this video and enjoyed this video, please share and subscribe, and it will keep me motivated to bring more such videos related to different concepts of data structure and algorithm. Thanks for watching. Bye.